Hello friends, let me solve one more example. You can see determine shear and momentum in the beam shown as a function of x. We have to determine shear force and bending moment as a function of x. You can see this beam, cantilever beam A and B, up to this point B there is uniform distributed load, and from B to C there is discontinuity in load. So when there will be any discontinuity in load, we can find this function of bending momentum and shear force up to B only, because we cannot find this. There will be two equations. One will be valid from A to B, and the second will be valid from B to C, because there is a discontinuity of load. So let we start. First we will find momentum at this point. So for that I have to find the support reactions. First let me find the support reaction. This is a fixed support, so this will give three support reactions. One will be momentum, I will write M, and another will be vertical force, I will write AV. I will write AV, and another will be horizontal force. This horizontal force will be 0 because there is not any horizontal force, so it is better if I don't write this. So this is A, and in this is a uniformly distributed load from A to B. I will write point load instead of this. That will be equal to area of this uniformly distributed load, that is 4 into this length into breadth. Length is 12 and breadth is 4, that is 48. That is 48 pound, and this distance will be, and this load will act on centroid of this rectangle. So this will be at a distance of 12 by 2, that is this will be 6 feet. And at this point there is another load of 60 pound, and this momentum also given as 100 pound feet. So I have to find these two unknowns, AV and M. First let me find this momentum. So I can write summation of momentum at point A equals to 0. This is point A, which further implies M minus 48 into distance is 6 feet minus 60 into distance is this total distance is 20 feet minus 100 equals to 0, which further implies M equals to 48 into 6, 228 plus 100, which comes out to be 1588 pound feet. So this is our momentum at this point A. Now we have to find vertical reaction at point A. So how can we find this? We can write summation of vertical forces equals to 0. So vertical force is AV. This is in downward direction. I will write minus 48 and minus 60 equals to 0, which further implies AV comes out to be 48 plus 60, that is 108. So this is 108. So now we have to find this shear force and momentum as a function of x. So we will make two functions. One will be valid from A to B and another will be valid from B to C. Let me first make first function. So I will choose a section here. Let me choose any section here in between A and B, and find at that section bending momentum and shear force. So I can write, I will draw diagram for this. Here momentum is 1588 and force in upward direction, that is 108 k, and this is load in downward direction. Suppose we cut a section here, we take this section. Now distance is x1, we take distance x1, this distance is x1. Now I will draw free body diagram for this section. I have to find this bending momentum m as a function of x and this vertical reaction v as a function of x. So I can write, this is free body diagram, 1588, 108, and this is m, this is vertical reaction at this point v, and this I will convert this uniformly distributed load as a point load. So I can write area is x1 into this height is 4, so I can write here 4x1, and this distance is x1 by 2 from this side, and this is x1 by 2. So but this function is valid from 0 to 12 feet. So I can write when x1 is greater or equal to 0 and less or equal to 12 feet, I can use summation of momentum at point. I will write summation of momentum at this point. At point, suppose we will take this point as S. At point S equals to 0, which further implies this 108 into distance is x1 minus this momentum 1588 minus, due to this force, 4x1 into distance is x1 by 2 minus m. This force is passing through the point, so momentum will be 0 due to this force, equals to 0, which further implies m equals to 108x1, sorry, this is minus 108x1, this is 108x1 minus 4x1 square by 2, this will be 2x1 square minus 1588. So this is the function of momentum, which is valid from x equals to 0 to 12 feet. Now we will find another function for this shear force. Now we will for finding this function, we will take summation of vertical forces equals to 0. So I can write 108 minus 4x1, this is downward force, minus v equals to 0, which further implies v equals to 108k minus 4x x1k pound. So this is function of shear force as a function of x, bending momentum as a function of x, but this is valid from 0 to 12 when x is 0 to 12 feet. Now we will find another function which will be valid from this x equals to 12 to 20 feet. So let me take another section here, and let me draw a free body diagram for this. So when we draw free body diagram, instead of this uniformly distributed load, I will write point load, and this load will not come here because this is on right side. So this is free body diagram. Here will be a single load, resultant load of this uniformly distributed load, that is 4 into x1, that is 4 into this distance is 12, that is 48 pound, and this distance will be this x1 by 2, that is 12 by 2, that is 6 feet, and this whole distance is this whole distance is x2. We take this distance as x2. Now we will find this function momentum and this shear function, but you have to remember that our x2 is greater or equal to 12 and less or equal to 20 feet. So let we start. We will first use this equation summation of momentum at point. Let me take this point as D. Summation of momentum at point D equals to 0, which further implies 108, because this is trying to rotate beam in upward direction. That is why we take this as positive, into x2 minus 1588 minus 48 into distance. Distance is this x2 minus 6 feet. x2 minus 6 minus this equals to minus m. Yes, momentum m. This is also trying to rotate beam in downward direction. That is why this is negative. Minus m equals to 0, and due to this force it is passing through this point, so momentum will be 0 due to this force, which further implies m equals to 108 x2 minus 1588 minus 48 x2 minus 48 into 6, 48 into 6, which comes out to be 228, which further implies m equals to 108 minus 48, which is 60 x2 minus 1588 228, which is minus 1816. So this will be function of momentum. This will be momentum as a function of x, but our x is varied from 12 to 20 feet. And now let me find this function for shear force. So we can write, for that we can write summation of vertical force equals to 0, which further implies 108 minus 48 minus v equals to 0, which further implies v equals to 108 minus 48, that is 60 60k. So if you find shear force at any point between this section 12 to 20, it will come 60 feet. Here if you find shear force here, it will come 60 feet, because this is free from this x2 or any variable. Hope you understood this. Thanks. Have a nice day.